you want to look at in the further math specification is the method of differences, and this is when we can add up sums using partial fractions and getting a large cancellation of pretty much all of the middle terms. So the one that's always referenced is the sum from k equals 1 up to n of 1 over r of r equals 1 up to n of r plus 1. They sometimes interchange the r's with k's. So first we're going to do the partial fractions. So this is going to be written in the form a over r plus b over r plus 1. If you don't know how to do partial fractions, I'll leave a video in the cards and in the description. But for now, this will just be a quick run through. And we can multiply up by r minus 1, so we know 1 is identical to a r plus 1 plus b r. Then comparing coefficients, we know that 1 is equal to a, and 0, the r coefficient on the left, is equal to a plus b. This implies b is equal to minus a, and that's equal to minus 1. So therefore 1 over r plus 1 is equal to 1 over r minus 1 over r plus 1. Okay, you can check that by doing the subtraction and you'll get back to this. So if we want to sum from r equals 1 up to n of 1 over r plus 1, sorry. Well, this is clearly the same as the sum from r is equal to 1 to n of 1 over r minus 1 over r plus 1. And we can just work this out explicitly, essentially. So for r equals 1, we get 1 over 1, so that is just 1. Let's write that a bit lower. Minus 1 plus 1, so that's 1 half. And then the next term is with r equal 2, and that gives us 1 over 2, so that's plus 1 half. Then we get minus 1 third, and 1 third, minus 1 fourth, 1 quarter. Hopefully you can see the pattern here. So we get loads of middle terms. Now we'll consider the second to last term, and that's going to be n minus 1. So we get 1 over n minus 1, and then we're going to get minus 1 over n. Then finally, with r equal to n, we're going to get 1 over n, not plus, sorry, minus 1 over n plus 1. And what happens, hopefully you can see here, because of the setup we've got, when we take the next term, r becomes the previous r plus 1, and we get opposite sides, so we just get all these cancellations in the middle here. Okay, this minus 4 cancels with a term here, this 1 over n to the minus 1 also cancels with a term here, these 1 over n's cancelled, and this whole sum for any value of n is just equal to 1 minus 1 over n plus 1. Okay, so that's a very nice technique. That's all we're going to look at in this video. I encourage you to practice this. So yeah, if you are asked to find a sum and you don't feel like you can use the rules given in the last further maths video for summation, then partial fractions may be something to try. And if you get a partial fraction formulation with this kind of pattern, it doesn't have to look exactly like this, but you're looking for at least a negative term so that you can get some cancellations and all that. And it might not cancel as nicely as this, but you can get some nice results with this method of differences technique. Yeah, so it's quite a nice trick to have, often worth quite a few marks on the paper as well, so be sure you are comfortable with this. Thanks for watching, and I hope to see you in the next one.